Finding the equation of a line. This is a very typical Core 2 style question where you're asked to find a line that passes through a circle or the line that passes perpendicular to the circle. And we're going to have to draw on some skills that we learned in our Core 1 topic. So, it says the line AB is the diameter of a circle centre C, where A and B are -1, 4 and 5, 2 respectively. The line L passes through C and is perpendicular to AB. Find the equation of L. So, the first thing to do is, as you can see, is to draw yourself a quick sketch. Now, you're not going to be given a grid in the exam. However, there's no excuse for you not quickly sketching yourself what the question is asking you to do. So, -1, 4 is here, and 5, 2 is here, and they are at the end of a diameter of a circle. So we've got a circle that goes around here, and these form the diameter of a circle. Now we're told that the line L passes through C, and we're told that C is the centre, so the centre must be somewhere around here. And we're also told that L is perpendicular to the line AB. So perpendicular means at right angles. So our line L is something like that. So we've got a couple of things to do in this question. So let's just label our two coordinates before we go any further. So that is A and that's B. First thing we need to find is we need to find the centre to this circle. And that's relatively easy to find the centre, because it's going to be the midpoint of our two known coordinates on the circle AB. So the midpoint is going to be the middle of -1 and 5. Well, 5 minus 1 is 4, and half of 4 is 2, so the x part is 2, and the middle of 4 and 2 is obviously 3. So the centre of our circle is 2, 3. Remember that L passes through this point, and that will be helpful later on. The second thing we need to find out, before we can find out what the gradient of the perpendicular line is, we need to find out what the gradient of the diameter AB is. So, remember from Core 1 that the gradient is calculated by finding the change in y, divided by the change in x. So let's use our 2 points to find out what the gradient is of the line AB. So the two coordinates we know are -1, 4 and 5, 2. So let's call the first one 1 and the second one 2. Remember, you've always got to take them away the same way. So if you're going to do 2 minus 1, you've got to do that in both the change in y and the change in x. So let's do that. So we're going to do 2 take away 1. So looking at the y parts first, so that's 2 minus 4, and in the x parts that's going to be 5 minus 1. So if we sort that out, that's going to be -2, and 5 minus 1 is 6, so it's 5 minus 2 over 6, which is the same as -1/3. Now if you think back to what you learnt in Core 1, you learnt that the gradient of two perpendicular lines, their product is always equal to -1. So the gradient of two perpendicular lines multiplied together is equal to -1. Remember, this is from Core 1. So if you can't remember that skill, just go back and watch the video from Core 1 on two perpendicular lines. So we know that the gradient of AB is now -1, 3, and we want to find out what the gradient of our line L is going to be. So minus a third times by our unknown gradient is equal to minus 1. So our gradient of the line L must be 3, because minus 1 divided by minus 1/3 is 3. So now, of our line L, which we're asked to find, we now know that it's got gradient of 3. We're also told, remember, that it passes through the centre C. So on our diagram we know it passes through the centre C. And we found out what our coordinates were for the centre of the circle, 2, 3. So if we substitute our centre, 2, 3, into this new equation, with a bit of luck we should find out our plus C value to enable us to find the complete equation for our line L. So if we substitute 3 and 2 into this, we're going to have 3 is equal to 3 times 2, which is 6, plus C. So C is equal to minus 3. This therefore means that the equation of our line L is going to be y equals 3x minus 3.